Okay, today we're going to talk about the Lewis dot and Bohr diagram, but we're focusing on this video on those Bohr diagrams. And so the Bohr diagrams are a simplified representation of those electrons in the atom. So when we talk about the Bohr model and we saw the rings, all right, or the energy levels, what the Bohr diagram does is represent to us what exactly is going on in each of those energy levels and how many electrons they have, not just the valence shell. And so there's just a few simple steps. So we're going to go ahead and write the protons and neutrons in the center, and then we're going to draw one dot for each electron. Now, depending on the energy level, they can hold a different number of electrons. And we see this on the periodic table. So in that first row, we know there's only two elements, right? Which is our 1s configuration, in the 1. And so that is only going to have two electrons. So this first ring can only have two. But then the second ring, our second row, we add on. We have not only the two here, but we also have 6 over here for a total of 8. And so that second energy level is capable of holding 8. And the same thing is true of the third energy level, which can also hold 8. After that, they follow right along with the periodic table, 18, 18, 32, 32. We're not going to get into anything super crazy, make you guys draw all those rings, all right? But we're going to focus mainly on the first 3 energy levels, okay? The same thing with the periodic table. You have to start in the lowest energy level, and you have to place one dot on each side before anyone can have 2 dots. Now, since that first energy level only has 2, right away you could fill a side. So 1, 2, showing that that energy level is full. But after that, you need to do 1 on each side. I'll start at the top, 1, 2, 3, 4, 5, 6, 7, 8, right? The same way we do with electron configurations and orbitals. All right, so let's go ahead and take a look at an example here. So if we picked out a random element here, let's say nitrogen, because it's a small one to start. Well, we look at it and we say, well, nitrogen has 7 electrons, okay? So when we look at nitrogen, we know, all right, we can put down right in the middle here that it has 7 protons, 7 neutrons, and then we'll start our ring. So now we put our first ring around that, and we know the first one can hold 2. Well, nitrogen has 7, so we know that that's going to fill right up. So that's 1, 2. And then we draw our next ring, and sorry for these circles being so terrible, but this one now can hold 8, but we only have 5 left. So we start at the top, 1, then to the right, 2, 3, 4, 5. And now we have our 7 total. All right. Nice, simple, there it is. Okay, let's see, what if we tried for magnesium? All right, and go ahead and pause the video, try to do this one yourself first. All right, hopefully you did that, and now we can go ahead and do it ourselves. So we know that it'll have 12 protons, right? It's number 12. It'll have also 12 neutrons. All right, and then we're going to put them in the nucleus. Now we draw our first ring, and we know this thing has 12 electrons. So we're going to put our first 2 right in that middle one, right? Meaning we have 10 left, so we got to draw a second shell. Now, right at the bat, we have 10 left, and this second shell only holds 8. So we can go right on by it. 1, 2, 3, 4, 5, 6, 7, and 8. And now we know we got 2 left, so we have to draw a third ring, And we can start right at the top. There's 1 and 2. All right, guys, so it's pretty nice and simple. All right, it correlates right with the periodic table. When you look at your actual rows, that first ring, it's past that, so you put 2 right in there. It's past that, so you put 8 in the second ring. And then you just have 1, 2 in that third ring because it's got the second spot. All right, correlates right in.